যদি আমি চালিয়ে নিয়েছি ওবিএসটা, মনে হচ্ছে কাজ করবে। ঠিক আছে, তুমি বেরিয়ে যেতে পারো।
ওকে, ঠিক আছে।
হুম। Well, good morning.
Good morning, sir.
Good morning, sir.
Okay, let me start today's class.
Good morning, sir.
Is the slide visible now?
Yes, sir.
Yes, sir.
Okay, so in the last class, we have seen various options of, combining if else in different types uh, to implement some of the typical scenarios of conditional branching. Okay, now today I am going to discuss another alternative which C allows uh, in many cases to replace the situation where we use if else if ladder. Okay, I mean, if you can recall, this was the typical form of if else if ladder when we have multi-way decision based branching. Okay, multiple branching is there based on certain conditions one by one. Now if the number of such ways or number of branches increases, it is very difficult to sometimes it appears to be very difficult to understand the exact flow of the control within this if else if ladder. Okay, so C offers another alternative which is called switch case. This is the switch is one keyword and case is also a keyword. So by combining switch and case, we can use this in many cases. We can use as a replacement of if else if pattern. Okay. Typically, when the number of branches in a multi-way decision is very large, and obviously there is some restriction. If else if ladder is most general, so we can actually implement any kind of multi-way decision based branching using if else if ladder. But using switch case there are certain restrictions, but in some cases it will be very helpful uh, to use switch case instead of if else if ladder. Let's see what is the typical form of a switch case statement. So it's like a switch case block looks like this. Hmm. It starts with a keyword switch, and within this parenthesis there is an expression or a single variable. Okay, and the entire switch block is enclosed within curly braces, and these are called sub blocks. Each of these sub blocks actually represents one of the multiple ways through which we need to branch. Like it may be thought of if, then else if, like that. Okay. So whenever the value of this expression or variable that is put inside the switch matches with this value, val 1. This is a value given, this first case level, then all the statement under this subblock gets executed. Otherwise, it is skipped and the next block is checked. If this matches with this value, then this statement get executed in this way. So if you can look, these sub blocks are again uh, distinguished by this case space, this value, this statement, and this break statement. Break is another keyword which acts as a delimiter between two different blocks. Understood? So different case levels are or case sub blocks are delimited by this break statement.
Sir, record.
Actually, this break keyword has several usage. We will also see some other example of usage of break statement later. But here in the switch case, the break is used to delimit from one block to other. Okay. Now there are certain important point we need to keep in mind while using switch case. I was talking about some restriction. Restriction is that this expression or variable that is used inside the switch must be an integer expression. Understood? As a single variable, there you can use a character, but that is because internally character is also treated as integer by C. So, in most important thing is that this expression may be the trivial expression of a single variable. This should be integer. You cannot use any float, double, or any other kind of data type or a mixed uh, data type or expression containing mixed data type. You cannot use. This expression must be evaluated to a integer. That is one restriction. Then these case levels, these are the value. These values must be constant, or some expression is allowed, but that expression should be constant expression. Okay, you cannot use any variable here under these case levels. Okay, so actually the expression will be evaluated to a constant always. So that should be matched with any of these value, or we call case levels. Okay, and it is quite easy to note that you don't need to enclose these sub blocks using curly braces, because this first statement case followed by the value and last statement break, these two are acting as the delimiter, so you don't need to explicitly enclose them within curly braces. So curly braces is mandatorily required only to enclose the entire switch block. Okay. And another important point to be noted that these case values or case levels must be unique within a switch. You cannot use duplicate values. Duplicate case levels are not allowed. Then errors will be generated. Okay, now let us see one example how it works. So first of all, as I have mentioned, this integer expression should be, I mean, the expression within the switch must be an integral type. A single variable integer or character is allowed because character is treated as an integer, or a complex integer expression like this. Okay, so this is one example. Here I have used int p equal to 5, and then I have used this expression p star 2, which is allowed because p is 5, 5 star 2, 10. So this is an integer expression. Now these labels constant integers 5, 10. So since it is 10, so this block gets executed. So this will be skipped. So this, if you run this program, this printf statement will get printed. Okay. Now, if I change this variable data type from int to any other value like float, then it will generate an error. So this is not allowed. Okay. You should remember. You cannot use a float or double or any other data type here because that time this expression would become a non-integer type, which is not allowed. Is it okay? Am
Yes,
I
sir.
audible, student?
Yes, sir. You are
Okay.
audible.
Yes, sir. Sir,
Okay.
please record the meeting.
No, record. See, I have already started recording using OBS Studio because Joydeep sir won't be able to present. That's why it is already being recorded. I will upload the recording. Hmm. Okay. So next thing, as I have said, you should remember this about case levels. It must end with a colon. Just like if you look into this general structure, see see this colon is very important. Case space by the constant value you want to match, then colon. This format is very strict. You have to remember. Okay, so it must end with a colon. As I have mentioned already, it must be a constant or a constant expression. Okay, so it either should be 2, 5, 10, some constant integer, or some expression like 2 plus 3 is allowed because that is evaluated as a constant expression. 2 plus 3 is 5. So this type of expression is allowed within case level, but not variable or any other expression involving variable are not allowed. And most importantly, it must be unique. Okay, two or more levels of a same switch cannot have same value. Okay, let us see some example of valid and invalid switch case. So this is quite easy to understand that this is okay because we have case values colon, they are integer type and they are constant type, so everything is okay, so this is okay. But if I change it, like here I have used z, which is a variable here, this is not allowed. It will generate an error. I cannot use any variable as case value. Okay, that you should remember. So this is not allowed. Similarly, uniqueness. See what I have done? This is 10 constant and this is 5 plus 5 a constant expression. But when it gets evaluated, it is exactly equal to 10. So both of these case levels are having same value, which is not allowed. Okay. So duplicate, I mean, the case levels must be unique within same switch. So this type of thing is not allowed. I mean, this 5 plus some other value, 7, then it will be okay. Okay, but 5 plus 5, since it matches with 10, or if it is 5 plus 5 and it is say 5 or some other value than 10, then also it will be okay. This type of expression is okay. There is no problem with this constant expression. But the duplication is the problem. I mean, you need to make it unique. Understood? Now, uh, Okay, no, this one. Now, what happened when none of these case labels match with the switch expression? Say I have written this program. Okay, now I am getting the value of P from outside. User has to enter the value. Now I have three case levels 5, 10, and 15. Now suppose user entered 7 or some value which is not 5, 10, or 15. Then what would happen? What do you think? Any guess?
0.
Hmm? Zero means? How this program will
Only
behave? Whether it will generate compilation error, or if it cannot generate compilation error, na? Because syntactically I have not done any mistake. So there is no point of generating compilation error, because it what I am telling, I don't know what value user will put. Okay, so syntactically this program is totally correct. So when I compile it, it will not going to generate any compilation error. Now when I am running, I am expecting that user will enter either 5 or 10 or 15. But it may so happen that user knowingly or unknowingly has entered some value which is not matching with this 5, 10, or 15. Then what would happen? What do you expect?
Nothing will happen, sir. It will not
I
execute
think
any of the statement.
I think it's a default not set.
Yes, since there is no default, so it will just silently skip everything, and there will be no output printed, but there will be no error generated. Okay, so that's why in switch it is in most common form, it is quite popular that we use a default case. Default. So default is written like this: default keyword followed by colon, and then there will be some statement, and there is no need to have a break there, because this is the last thing. So no need, this is optional. So it is always good to keep a default block within switch, so that when none of the case labels matches with your input, then this default action will be taking place. Understood? So in this way you can use a default if you wish. Default case label. Understood?
Yes, sir.
Yes, sir.
Okay. Now what happened if a break statement is missed unintentionally? Like as I mentioned, every case block must end with a break. Okay. I mean the last block is not necessary. It is optional. But suppose in some other block I have forgot to give. See here the break statement is missed. I have forgot by some means. Then what would happen? What do you expect? Will it generate any compilation error?
No, sir. It will
No.
print
Huh?
for case 15. It will print the printf statement for case 15. It will also print the printf statement of
Exactly. So
case.
remember, this is very important to note. It will not generate any compilation error. Even if you have not given any break statement, if you missed unintentionally, completely just by mistakenly, compiler will not generate any error. But what would happen? As I mentioned, these breaks actually act as a boundary between two sub blocks. Okay. Now, when there is no break, it will actually go if you input 10, then obviously you expect that this printf statement should be printed only. But since there is no break, it will come to this block also automatically without checking anything, and it will print this also. So as if there is no boundary between these two blocks. Okay, so you will get unexpected result. You wanted to print only this is case 10 when 10 is input, but you will get instead you will get output like this. This is case 10 and this is case 15. Okay, so be cautious about this break statement because it will not be caught by compiler. You have to keep in mind. It is not a syntactical error. It will generate or create logical error. Okay. Now, sometimes it is very interesting to see. I mean, I'm showing two program where sometimes you may find it very, I mean, desirable. Sometimes intentional omission of break statement may help you to code better. Okay, this is very interesting observation. In some cases, it will help you to write your program uh, more sophisticated manner. Obviously, using break statement or and every case levels, it will be doing. But just sometimes some intentional omission of break statement may help you to make your code smaller or more look like very um, simple. Okay, let me show these two program one by one and illustrate that point. Okay, this, let me hide this one. So first one, let me show the normal switch case one where this is the example. So how this if else if ladder can be replaced by this switch case. You see, we had written a program earlier using if else if ladder to determine or compute the grade from the marks obtained. It was there, na? Now let me just comment this entire block. What I am doing, you see, I am commenting this block and uncommenting this switch. Are you getting my point? How I'm just replacing the same thing I had done using if else if ladder by this switch case. Okay, what I am doing now? I have got the marks obtained. Now, instead of taking the direct marks obtained here as a expression, I am dividing it by 10 because I know if somebody gets 90 or above, this division will result 9, and if somebody gets 100, this division will get 10. So these two case level grade should be assigned X. Look at this, especially beginners, whether you are getting this point. I am not using directly marks obtained in order to make this number of cases smaller than required, because if I need to consider the marks obtained, then I had to create probably 100 case levels, because for every possible marks obtained number like 100, 400, there would have been one case level, from 99 for 98 down to 0. So 101 case level would have been there. But in order to compact that, what I am doing, I am dividing that by 10. Understood? Obviously, here I have assumed that grade P is assigned for marks obtained greater than equal to 40, not 35. Because if I consider that 35, then I cannot use this expression. I had to use it by 2 into it, and I have to use all multiple of 5 as separate case levels. And so instead of this 10, I should have, I could have, I mean, 20 case levels. But here I have just make a change that marks obtained greater than equal to 40 is P, and less than equal to 40 is considered as F. Okay. So just check whether the same thing is being done by the switch block or not. Student, please respond whether you are getting this thing.
Yes, sir. Yes, sir. I get it.
Okay. So if I compile and run, I'll suppose I give 72. So the grade obtained by the student is B. You can check. I will upload this again. You can check. So these two are equivalent. Either you can use this if else if ladder, or you can use this switch case in these circumstances. So we are free to use. Now, so this program is working when our F grade is assigned less than 40. But in NIT Durgapur, we know that F grade is assigned for less than equal to 35. Now, as I mentioned, if I need to consider that thing there, then in if LC block, it was quite easy. I mean, I can write LC marks obtained greater than equal to 35. That change would have been sufficient to incorporate that. But here, what I had to do, I had to make it 20, then like this 5, okay, and then anything like this 9 and 8. 9, any marks you say 9, 80, so case, not case 5, 25 and 4. How I have to change? Any marks obtained, suppose 100 means 5, fine. 99 means how much? Any 90, 20 by 90, how much it will be?
4.
So it
Then,
will be 4, not 9. So
oh,
next
no, no,
will
no,
be
actually
case will
not
be 4.
20. I have to divide it by 5 actually, and I have to consider all this 20, and then I have to make it like,
Oh, 20, 19, 18,
yes,
like that.
yes.
Sir, if we introduce an if statement at case number 1, if the marks obtained is greater than equal to 35, then print this, and
And
if
that, see, I am just talking about straightforward equivalency between if else if ladder and the switch case ladder. Okay.
okay, sir.
Okay.
Okay, sir.
So I have to consider all. Now, in order to consider the 35, if I go on implementing the switch case straightforward, then I have to consider, instead of 10 levels, I have to consider 20 levels, and per each grade I may have multiple levels, like same 19 and 18 and 20. Three case levels will assign grade X. Then maybe 16 and 15. Both of them will assign, not 16 and 17. Both of them will assign A, like that. So for every grade, now we are having only one case level, except X. But in that case, we will have, for every grade, we will have two case levels. And for X, we will have three case levels, 20, 19 and 18, like this. This will be 18, and then this will be 17, will be A, and this will be 16 A. Then in this way I have to write 15 B and 14 also B, like this. Understood? In this way, I'll go up to this P similarly, and then finally this F will be coming. So it is not complete yet. Let me show other program where I was trying to say that how intentional omission of case level can, break statement in case levels may help us. See, now what I am doing here, I am trying to implement the gradation terminology followed by our institute. So I have divided it by 5, and so case 2019, instead of writing the same thing again and again, I have just omitted the break statement. So how it will work? Any number you put which belongs to this X category, it will automatically come to this statement because there is no break statement. So I don't need to, instead of writing this everywhere, instead of writing the same set of statement everywhere, what I am doing, I am just omitting everything here, because all these 3 case levels should assign grade to be X. So I am intentionally omitting the break. So any number you put between 90 to 100, it will actually come to this statement. Understood? Similarly, any number you provide between 80 to 89, it will either match this or this. So since there is no break statement delimiting them, all of them will come here and A will be assigned to the grade. Are you getting my point? How just intentional omission of break statement makes my job a little bit clearer?
Yes, sir. Yes, sir.
So this is one way. We can check. We can run it. Any number you provide now, 76, grade is B. Any other number, say you get 54, grade is D. Now let us see P, or between some P or, so 36, say the grade is P. Okay, and anything below 35, let us check, 20, 31, say, so grade is P, F. Okay, so this is another usage. You should remember that how you can just uh, use break statement appropriately in switch and case to make your job more easier sometimes. Okay, next, let me quickly, as I mentioned in the last class, I will just quickly show you that we have got so many options, so many different types of uh, branching. Okay, now how to choose the most appropriate branching in solving one particular problem? We can do many things using different combination of if, else, which. Okay, so all of them are allowing us to implement some kind of uh, decision making based branching. Now we'll see that same problem can be solved using different variants of these options. Now which one should we choose? Should we choose any one arbitrarily? No, actually, depending on the situation, this is one, I mean important point to learn in any kind of programming, that where and when we should use what. There are different options given. Now, not always whatever coming into my mind, or always using the same kind of uh, options given to solve all types of problem. may not be beneficial. You need to understand, you need to learn how to look into different scenarios, how to identify different scenarios, and how to apply different options elegantly. Okay, I am illustrating one such observation by using this small problem. This problem has been discussed many times so far in the course. Finding the largest among three distinct numbers. Very, very simple example. Don't consider this problem only. I mean, don't consider that this problem is very important to solve. But with this simple example, I want to highlight some general points that you should try to understand and apply in future. Okay. Now, this you know how to solve this problem. When you are given three distinct numbers, which you cannot, basically analogously, you can think that there are three objects. They are holding some values or weights. Now you are given this simple weighing machine, but these weights are not available to you. That means there is no way you can look into the absolute weights or absolute value of these objects. You have to find out the largest or greatest or weightest, having most weight, just by comparing. You have this machine, but not this. So you cannot get the absolute values. And the challenge of writing a program is also this, because you don't know, when you are writing the program, you don't know what actual values this variable a b c will hold, because during runtime user will give, sometimes a may have some value which may be greater, sometimes b may be greater, sometimes c may be greater. So you cannot really depend on the absolute values of abc, but you can assume that you have this machine, so you can compare which one is larger and which one. Just putting a on this side, putting b on this side, you can check at that point whether a is heavier or b is heavier. Similarly, taking two objects at a time, you can just compare their relative weights or relative uh, values. Okay, so how do you write that program? So most intuitive solution and most common, many of you tempted to write this particular code, that you will ask the user to enter the number abc, and then you will write an if statement. If a is greater than b as well as a is greater than c, then a is the largest number. Then there will be another if statement considering b is greater than a and b is also greater than c, then b. So every time you are checking whether you are considering one object at a time, and you are checking whether that is greater than both other two objects. Then you are declaring that. Otherwise, you are going to that next step. So in this way, you are basically considering A, B, and C separately and doing the same thing. You are comparing with others and finally declare. Many of you may have written this code. This code is exactly right. It will generate no problem. It will create. It will give print the largest number in any circumstances. But the problem is that, see, since we are repeatedly using if statement, we are basically doing the same experiment several times, same comparison. See, here I am comparing between A and B. Suppose I have found it, okay, it is A is greater than B. But when I am comparing A with C, I am getting no, A is less than C. So I have already done these two comparison. But here what I am doing? Again I am doing the same thing. I am again comparing between B and A. That means A and B. Okay, same redundant thing I am doing to check or to finally decide which one is the larger. So in total, in order to get the largest among three numbers, how many comparisons I am making? Can you tell me? In the worst case?
6.
6. 6 comparison.
Six.
And out
Six.
of that 6 comparison, I mean, every pair of comparison are redundant. I am doing the same thing. I am not keeping this. I have already found that A was greater than B, but here I am again doing the same comparison to check whether B is greater than A. This type of thing, it's not incorrect, but this is inefficient. Okay, so can you do better? Can you just write a program where I will do it using less number of comparison without any redundant thing? So that's what the planning comes. Without instinctively starting writing the code, you need to think. You need to think how you should solve the problem. That means that algorithmic thinking you have to do. You have to use some of the tools to explore and then finally come up with the solution to find out a better possible solution. Let me show how we can do. So basically, let us plan systematically to design the solution. So basically, when if A is greater than B, if that is true, then I have to just check if A is greater than C. So if true, A is largest number, fine. But I will not leave here. I have already found out this is a nested if kind of thing is coming. That A was greater than B, but A is not greater than C. Then instead of going to another if, I am just checking whether that means C is greater than A. So I can declare here that C is the largest number because A was found greater than B. That's why I have come to this block and there I have found A is not greater than C. That means obviously C will be the largest number. So I am not repeating. I have just between A and C, A and B, that comparison I have made once, and based on that I am doing other comparisons. And whatever results I get, I am using both positive and negative results in efficient manner like this. So in flowchart manner, it will look like this. If A greater than B, I will go this path to check whether A is also greater than C. Yes, so I will be printing largest. If this condition become false, I will come to this. If the initial checking was false, then I would have done this thing. Okay, so these are the branches I am taking during runtime. Any one of them will be taken. Any one of them. There are 4 branches. And see, every branches only 2 comparisons I am making. So instead of making 6 in the worst case, as my earlier program was doing, obviously in the earlier program it was not always 6. It may vary. It may vary. Sometimes only 2 comparisons would work. If A was found to be the largest number, then only 2 comparisons will do. Okay, but here I have to give and some other mechanism. But in this trivial problem, obviously it will perform 6 times always because I am not doing anything. But here it is quite easy to see that at any for any particular combination of input, only 2 comparisons, either this and this or this and this will be done. And based on their values, based on the result they return, the combination true, true or true, false in this side. and similarly here true, true and true, false. These four combinations will result these four possible outcome. Out of that, these two will match with C and these two will be two different. So in this way, if I efficiently plan before writing a code, I would have write this particular code, which will be more efficient. Both of them are correct. The earlier one was also correct, but this will be more desirable. So there are two takeaways from this particular discussion. That is, same thing can be done using different combination of constructs that are supported by any programming language. And the second takeaway is the most important thing, is that we need to think a bit and plan the solution instead of just instinctively starting writing the code. We should think that what are the different possibilities through which we can solve the problem and which one will be more efficient for this particular problem. Then after planning is done, then you start coding. Okay. Now situation may become different if the problem changes a little bit. Like, so far we were considering finding the largest among only three distinct numbers. Now if I extend this problem to find the largest among any n number, and which is very uh, appropriate for a computer program. I mean, you will never write in practice a program to find out the largest among only three distinct numbers. You will write programs for finding largest among some large number of distinct numbers, say some variable n. Okay. In that case, then you will find this type of nested if else will not be efficient. Okay, because that time this type of, see, this is another way of finding largest among three. What I am doing? I am using a separate variable, initializing with one of the number, say a, without loss of generality. Then I am checking whether b is the greater than current largest. Then I am updating the largest with b. Otherwise, the largest will remain as it is. Then again I am coming to check whether c is greater than largest. If it is so, then largest will be content of the largest will be updated by C, otherwise it will remain. This will also going to print the largest among three numbers. Understood? But here what I am doing, instead of two comparisons, I am using one assignment. This assignment is extra, and two comparisons. Although this is a little bit less efficient than the earlier one for finding largest of among three distinct numbers, but we'll see that when we will be asked to write a program to find the largest number among any n distinct number, then extension of this particular strategy will be beneficial, because otherwise going so many levels of nesting going so many levels of nesting is not good. This is not good. When n is very large, so how many nesting you will do? If, then if else, then within that if another if else, within that if another if else. So it will be very cumbersome. So instead of doing that, this natural extension of this strategy, which may be a little bit less efficient for only three numbers, but we will see this will be most efficient for finding largest or smallest or similar type of thing, which we will discuss in due course of time. But you can also think that how it can help. Just consider this program, and then you see how it will be, the extension of this will be better. Okay. Hope you have understood a little bit about
Yes.
the and how to apply different types of options given, how to understand the particular scenario, which one will be best fit. Okay.
Okay, sir.
So is there any
Uh,
other question from you?
স্যার
Hmm.
স্যার বলছি যে স্যার আগেরটা একদম প্রথম যেটা করেছিলাম সেটা হচ্ছে ছখানা কম্পিটিশন করেছিলাম।
হ্যাঁ হ্যাঁ বলো।
তারপর স্যার চারটে, কিন্তু এটা দুটো করছি, তাহলে এটা দুটো যেখানে কম্পারিজন করছি সেটা আবার কম এফিসিয়েন্ট হলো কি করে, এটা তো বুঝলাম না।
না না, দুটো কম্প্যারিজন আর একটা অ্যাসাইনমেন্ট আছে না এক্সট্রা,
আচ্ছা স্যার।
সেই জন্য বলছি লিটল বিট। মানে আমি তিনটে দেখালাম, আই হ্যাভ শোন ইউ থ্রি অপশনস ফর ফাইন্ডিং লার্জেস্ট অ্যামং থ্রি নাম্বারস অনলি। ফার্স্ট ওয়ান ওয়াজ 6, having 6 comparison. Second one was exactly 2 comparison, and third one was taking one assignment and 2 comparison. So I am also taking that assignment because all these assignments comparisons are operation for which our CPU will be involved. Okay, but my point is that when we'll deal with n numbers, not 3, 4 or 5, we'll deal with large number, then this third one, the extension of the third one will be beneficial, not only in terms of number of comparisons, but also you have to always see how efficiently you can plan your algorithm and implement your algorithm, and so others can understand your code. Okay, so writing a nested if else for quite deep, it will be very difficult to understand the logic or follow the logic of your code. Okay, so that's why it is not recommended. Nesting,
ওকে স্যার।
I mean, to a deep level of, so many, 9, 10 levels of nesting is not recommended, although it is allowed, but it is not recommended. Understood?
ইয়েস স্যার।
Is there any other question?
Sir, in the lab class, question number 2, which you given, that question I have problem.
So in the lab class we'll discuss. Okay, next Wednesday you just present and then discuss about that.
Okay, sir.
Okay. Okay, if you don't have any further question, we can conclude today's session.
Thank you, sir.
Okay, welcome.
থ্যাংক ইউ স্যার।
Thank you, sir.
Thank you, sir.